This is Unit 3, Linear Relationships, Lesson 3, Representing Proportional Relationships. And this is Activity 2, and this is Part 1. This is Jada and Noah walking, which is Part 1 of the activity called Representations of Proportional Relationships. So I'm going to break this Activity 2 up into two videos. One part is Jada and Noah walking because we're going to go through the four different representations of proportional relationships, and it takes a while to get through these. And so those four representations are the verbal description, a graph, a table, and an equation. You have done each of these separately, and now we're going to start putting them all together. They play off of each other. Usually you can get from one representation to the other no matter where you start. Usually you start with the verbal description because you have to understand or know what the story is. Although sometimes you're asked to make up a story based on a graph or a table or an equation. So here's the verbal description. Here's the equation over here. And it asks you to create a table using three different coordinate pairs in that table and graph this relationship because you have those three different coordinate pairs. And so this is the description. Jada and Noah counted the number of steps they took to walk a set distance. To walk the same distance, and you could say that that's approximately 10 yards. Because Jada took 8 steps, Noah took 10 steps. Usually when an adult takes large steps, that's pretty close to a yard. So this is somewhere between 8 steps, 10 steps, here's 12 steps. So we're talking probably about yards in this case. But that's the same distance. And the question is, how many steps does each person take to cover that 10 yards or that same distance? And so Jada takes 8 steps, Noah takes 10 steps. If Jada takes 12 steps to cover the same distance that Jada covered, now she's going farther in this case, Noah has to take 15 steps. So notice, we'll look at a little line graph of this in a second, but Noah's taking smaller steps. He's covering that same distance, but he's taking smaller steps. Jada's taking larger steps. Then they found that when Noah took 15 steps, Jada took 12 steps. So this is the beginnings of a little table. And you can see that the two properties are, one property is Jada's steps. She's going to be on the x-axis. And the other property is Noah's steps. He's going to be on the y-axis because it's going to tell you that in a moment. So y equals 5 x. This is the equation. So what does that mean? Well, it means that 5 means the same number of steps, which is 4 plus 1/4 more of that number. 1/4 of that number more equals 5/4. So if Jada takes 4 steps, 1, 2, 3, 4, Noah takes that same number of steps, 1, 2, 3, 4, plus 1/4 of his steps. So he takes 5/4 steps. So one whole step, 4/4, plus another 1/4 of a step to cover the same distance that Jada covered. So he's taking smaller steps to cover the same distance. Jada's taking larger steps to cover that same distance. If they took the same number of steps and the question was who travels farther, well, Jada travels farther. In 4 steps, she covers this distance. In 4 steps, Noah covers, by the way, that would be 4/5 the distance. And we could spend some time thinking about that. All right, the equation, let x represent the number of steps Jada takes. So they give that to you. They don't actually have to give that to you. You could come to that conclusion by working through the problem. And let y represent the number of steps that Noah takes. So y is Noah. That makes sense because Noah takes more steps than Jada takes. If Jada takes a certain number of steps, Noah takes that same number plus another 1/4 of that number of steps. So he takes 5/4 the number of steps that Jada takes. So 5/4 is greater than 1. So Noah takes more steps than Jada takes. So 5/4 x is greater than x. It's more steps. So 5/4, this is the same graph I just showed you. 5/4 means the same number of steps, 4/4, plus 1/4 that number more equals 5/4. So the number of steps, once again, that Noah takes is greater than the number of steps that Jada takes. So her number of steps is going to get multiplied by 5/4. Here's that equation. So now you just start to see it. So this has to be Noah because he takes a larger number of steps. This has to be Jada because she takes a smaller number of steps, and her number of steps gets multiplied by 5/4 to get to Noah's number of steps. So this is a good activity right here for you to do to practice what's going on. Just put the equation in front of you with nothing else and see if you can explain what it is. Maybe even write it down in words, what each of these numbers tells you, what has to be true about the situation based on the description. All right, so Jada's x, we usually place the x on the left side of a table. Noah is y, we usually put the y values on the right side because we usually know the x information. That's what's given in most cases. And you calculate the y value, which is the answer to that question. And you use the constant of proportionality. If this is a proportional relationship, you use the constant of proportionality to make that calculation. I'm going to come back to this in a few minutes. But in this case, if Jada walks 8 steps, then Noah walks 10 steps. So how do you get from 8 to 10? You multiply that by that 5/4. If Jada walks 12 steps, Noah walks 15 steps. How do you get from the 12 to the 15? You multiply by that 5/4. If Jada walks 4 steps, Noah walks 5 steps. How do you get to the 5? Multiply 4 times 5/4. We're going to go through this in just a second. So once again, here's the visual picture that you have in your head. Number of steps that Noah takes, that's more. He takes 5 steps for every 4 steps that Jada takes. So to walk that same distance, Jada takes 4 steps and Noah takes 1/4 more that number of steps. All right, so to get to the constant of proportionality, and we did this last year in 7th grade, you take the y value and you divide it by the x value. But we've also done it this year. This is the slope. This is the, and we're going to look at the graph in just a second, but this is the number of units in the vertical direction, that value, that ratio to the number of units in the horizontal direction. That ratio is 5 to 4. That determines both the constant of proportionality and a proportional relationship, also the slope of the line. And notice that if you divide 5 by 4, you get an answer of 5/4. This is always true. So you can take the 5/4 and just write it over 1. That is the fraction. And so you just write it over 1. And we usually just write it as 5/4. It's a little bit confusing then because these look exactly the same, but they're actually different situations. This is 5 steps that Noah took for every 4 steps that Jada takes. This is 5/4 of a step for every 1 step that Jada takes. So this is called the unit rate. How far does Noah go in just one of Jada's steps? So this is the unit right here, 1 step that Jada takes. How far does Noah go? He goes 5/4 of a step. So this is called the unit rate. 0,0 is undefined. You don't write that as a ratio or a fraction. It's a proportional relationship. It goes through 0. So if Jada has taken 0 steps, Noah has taken 0 steps. They've gone 0 distance. 15/12. If you write it as a fraction now, it's 15/12. 15 divided by 3 is 5. 12 divided by 3 is 4. And so that gets the same constant proportionality as down here. So since these are all the same, they are all constant, it's further evidence that this is a proportional relationship. 10/8. 10 divided by 2 is 5. 8 divided by 2 is 4. So again, 5/4, 5/4, 5/4, and 5/4. It is constant, doesn't change. It's the constant of proportionality because it goes through 0. So every single value that you have for x, you multiply that value by 5/4, and you get the number of steps that Noah takes, the y value. And so go back to what you know. This is everything. I'm going to go through this step by step, but this is everything all together. This is where we started a long time ago, how to write this equation as the ratio. And I'm going to go through this right here. So if you have y equals 5/4 x, that comes from looking at the slope triangle, and the number of steps in the vertical direction, the y value is 5. The number of steps in the horizontal direction is 4. So that determines the slant of this line, how steep it is or how shallow it is, based on this ratio of 5/4. And so that ratio in this case is 5/4. So the vertical direction is 5, the horizontal direction is 4. And because this rests right against the origin at 0, 0, the number of steps, or the coordinate 4 in the horizontal direction, is the number of steps in the horizontal direction. You don't have to subtract. Remember, we used to have to subtract. If this slope triangle was this direction at all, we would have to subtract the number of units along the x direction to get it to 0. So this value would be x minus something. And this value would be, if the slope triangle was shifted up here somewhere, this value would be y minus something. But because this slope triangle is already against the origin, you don't have to shift anything. That makes writing this equation much, much easier. If you remember over here, we'd have to have that shift. It'd be y minus something over x minus something. But again, since it's right here, there is no shift. Some cases it was down here and we have to add to get to 0, 0. So this makes it much easier. The vertical distance is 5/4 the horizontal distance. So now you can just say in words what this means. This means that the vertical distance is 5/4 that horizontal distance. So this vertical distance right here is 5/4 this horizontal distance. That's what this ratio means. And so then we practice saying this in words. The vertical distance is 5/4 the horizontal distance, and realize, well, that just helps you write the equation. Y equals 5/4 x. Now there's a mathematical way of doing this, which we'll get into later on, but you can just use the language to check yourself. It makes sense. It shows you that this is the proper equation. It's a different form of this that makes sense, because y is 5/4 of x. Y is 5/4 of x. So the y value is 5/4 the x value. There's no shift. That's the big deal. That's why it's a proportional relationship. It goes to the origin. So that's why you get this constant of proportionality. The y value over the x value remains constant. All right, so the graph. We know that the x-axis is going to be Jada's steps. So that's the label of the x-axis. We know that the y-axis is going to be Noah's steps. So this is the label of the y-axis. And if you look at the table, Noah's steps goes out to 15, and Jada's steps, the highest number of Jada's steps, is 12. So you use those numbers to figure out where to place your scale, how far out to go on your scale. So now I just numbered, so it goes through 0, 0. And now I just numbered, this goes out, Jada's steps went out to 12. So if I just put one step per line, I can get out to that 12, and I actually can get a couple extra steps if I need them. And Noah's steps go out to 15. Well, this is one line short, so I just measured the same distance up here and labeled that 15. I could have labeled this 2, but that wouldn't go up very far, and you might as well just add one more unit to make this 15. So this is the number of steps that Noah takes is 15. And then just start placing the points. From your table, you can see that Jada takes 4 steps, so you go out to the 4. And for those 4 steps, Noah takes 5 steps. He takes more steps. How much more? 1/4 more. So he takes 5/4 as many steps as Jada takes. So you go up to the 5 and you go over here, and that shows you that the relationship just shown in this single point here is the relationship between the number of steps that Noah takes, 5, to the number of steps that Jada takes, 4. So that's what that single point tells you. That's why graphs are so powerful. A single point tells you quite a bit of information. Then if you put more points together, you get the line, which even gives you more information. So if you double the number of steps that Jada takes from 4 to 8, you also double the number of steps that Noah takes from 5 to 10. That is a proportional relationship. One number gets doubled, the other number gets doubled. One property gets doubled, the other property gets doubled. So this goes out to 8 and goes over to 10. And if you triple the number, 3 times 4 is 12, 3 times 5 is 15. Again, a proportional relationship. If you multiply one property by 3, the other property will be multiplied by 3. That helps you figure out different values. Then you get a line, and every point on this line has that same relationship. That's the value or the power of drawing the line. So now you don't have to do the calculations anymore. You just use the graph to tell you. Let's say that Jada took 11 steps. How many steps does Noah take? You go up here and you go over here, and you can estimate it's about 13 3/4 steps. Since these were all fourths, probably is 13 3/4 steps. And 10 steps up to here, and this is going to be 12.5. Since these were all fourths that we were talking about, these are all, this is 1/4 up, this is 3/4. So these are all fourths. This is 1/2, this is 1/4. I'm talking about the distance between these two lines in each case, because these were all divided into 4 equal parts, because we're talking about Noah's steps were 5/4 of Jada's steps. So you're going to continue to multiply by those fourths. So y is equal to 5/4 x. This is the equation, so you can start to see, and if you can think about that other form, it was y over x equals 5 to 4. And here's the slope triangle once again, and so this gets you out to 4 and up to 5. So now let's zoom in at 1 unit. So let's talk about the unit rate. So that's the constant proportionality at 1 unit along the x-axis. So if Jada takes a single step, how many steps does Noah have to take to cover that same distance that Jada takes in that one step? So you go up to here, and Noah has to take more than 1 step. And how much more? He has to take 1/4 of a step more to get out the same distance that Jada took in her single step. So this is 5/4. So I just showed you that every time you go up by a unit, you're going to go up by a number of units plus a fourth. Sometimes it's 1/4, 2/4, 3/4. If it's 4/4, you go up 1 more unit, and get a little bit confusing here. So let's just keep it at a single step. For Jada is 5/4 steps for Noah. So y is equal to 5/4. Once again, this is called the unit rate. So 1 unit, 1 of Jada's steps equals how many units for Noah? It equals 5/4. So again, the unit rate. So remember the 4 representations. You have a graph. From the graph, you can write the equation. You can also write the equation from the table by getting the constant proportionality. So y equals 5/4 x. So this is the graph. This is the equation. This is the table. You use the table, the values in the table, to draw the graph. You can write the equation either from the table or from the graph. You can count the number of units in the x direction, the number of units in the y direction to write the equation. You know it's just y and x because it goes to the origin. These are the kind of things to do on your own. look at the figure and talk through it. What is it telling you? And write some words. That would be the studying. That would help you develop an understanding of what's going on. It's the four representations: description, graph, table, equation. These three, once you have the description, then you can write these three. Sometimes in some activities, they're going to ask you, they're going to give you some of this information and say, make up a story. You come up with the description that follows this graph, or that follows whatever the values in the table, or maybe they'll just give you the equation and ask you to make up a story based on that equation, to complete a table based on that equation, and to draw a graph based on that equation. And this would be the description once again. So the four representations are right here. And this is the first activity. I'm going to go through the second activity in a few minutes.